About the stalker grandma. Do with you. All right, number 3. Take the derivative, set it equal to 0. Yeah. Okay. Oh, I thought you said number 3. I thought somebody said number 3. You need number 3. Okay. All right. So for number 3, we have to use our old friend, the quotient rule. Who doesn't love the quotient rule, Shaden? That's the question. Low. Low d high. H prime is probably the derivative of high. That's the notation that you're using. Okay. So H stands for high. Prime stands for derivative. So low d high. Okay. Mm-hmm. Okay. Then for fractions, to set them equal to 0, you only have to worry about the top equaling 0. So get rid of that stupid stuff on the bottom. So 3x squared plus 3 minus, in parentheses still, 6x squared minus 8x equals 0. So I distributed the 3. I distributed the 2x. I did not yet distribute the negative. I will do that now. So negative 3x squared plus 8x plus 3 equals 0. Yep. I did 2 things at once, yeah. Are you good to hear? Okay, the negative here makes this a negative 6x squared, but the 2 things I did at once is the 3x squared minus 6x squared is negative 3x squared. And then the negative and the negative make a positive, and then this guy's just hanging out. Okay? Okay, you guys want quadratic formula, or you want the weird... You can factor it. Okay, quadratic formula. So x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all divided by 2 times a, which you don't have to memorize anymore because it's on the wall, in front of the room. There you go. Yeah, like royalties, kind of. Every time someone uses your song, you get a little something, something from that. Yeah, you're monetizing people's eyes. Yeah. All right. So this underneath here all works out to be 100. So that's fun because the square root of 100 is just 10. So negative 8 plus or minus 10 over negative 6 is one answer would be 2 divided by negative 6, which is negative 1/3. The other answer would be negative 18 divided by negative 6 would be positive 3. Okay, well, no, what we found was the critical points of the function. Okay, the places where the derivative is 0. Now, technically, we would also figure out where the derivative is undefined, but this never equals 0, so we don't have to worry about that. What'd you say? Can't use 3. Why? Because outside the interval, so the only 3 numbers that you have to worry about are negative 2, negative 1/3, and 2, and yes, you just plug those back into the original function. I don't know. I shouldn't have to do that for you. Okay. Change the answer. All right, next one, number 4. We have to start the same way. by taking the derivative. If you were a desperate man like Gage, then you could like FOIL that out. And so you could FOIL that whole thing out and then take the derivative that way because you're not comfortable with the chain rule. But let's go ahead and practice the chain rule. So what do you do first? Put the 3 in front. Okay. Yeah. So you just do the power rule on the whole thing. And then, yeah, you can thank my first period class for that again. Yes, I don't know why they do that. You turn the heat down, it gets cold in here, and then I turn the, or is it you guys on your way in? I don't know. Okay, so now I need to FOIL this. So that would be x to the 4th plus, if I multiply those together, that's 2x cubed doubled is 4x cubed. That squared is 4x squared times 2x plus 2. So this isn't really much better than FOILing it all out in the first place. 3x to the 4th plus 12x cubed plus 12x squared. This one right here, I squared that. And I just know how to do that in my head. The way you square a binomial is you take the first term and square it. You multiply these two terms together and then double it, because that's going to be inside and outside, so when you add them together, they're going to double. So 2x times x squared is 2x cubed, doubled is 4x cubed, and then this squared is 4x squared. So I just did that without writing it out, because, you know, calculus. Then I distributed the 3. Oh, get over yourself. You're wearing shorts and everything is fine. Distributed the 3. Now I'm going to multiply everything in here by 2x, and then I'm going to multiply everything in there by 2. So 6x to the 5th plus 24x to the 4th. Come on. Come on. Hence the new computer. There we go. 24x to the 4th plus 24x cubed. Then I'm going to multiply everything by 2. So that gives me 6x to the 4th plus 24x cubed plus 24x squared. So I've only got that one term to the 5th. Those two are both to the 4th, so that's going to be 30x to the 4th. Then I've got two things to the 3rd, so I'm going to combine those and get 48x cubed. And then I just have that x squared by itself. Payson? Yeah, tomorrow. Yeah. That's why we're doing this. Yeah. These ones right here. Okay. I went through and I multiplied all of these numbers by 2x. And then I had to go through and multiply all these numbers by 2. So the first three numbers are what I got when I multiplied all of these by 2x. And then the last ones are by 2, yeah. Okay? And then I just combined like terms. Okay? Okay, anybody see anything I can factor out of there? Factor out of 6x squared. Good. So I'm going to factor out of 6x squared. Leaves me x cubed plus, can't read my own writing, plus, oh yeah, in fact, I'm dividing by 6. Thanks. So, okay, so what's this answer right here? 0. All right, you guys are going to love this. I have to solve now x cubed plus 5x squared plus 8x plus 4. And coincidentally, we just had that up there on the board from my other class. The way that we're going to do that is by using synthetic division. Because I don't know how to factor that. So 1, 5, 8, and 4. There is, but it's a beast. Remember that in synthetic division, my options for this are plus or minus factors of that. So we're looking at plus or minus 1, plus or minus 2, or plus or minus 4. And it's just a guessing game. So Payson says 2. 2 times 1 is 2. That's going to, no, I don't like that. Do you guys see how we're going to need a negative? Right? Because this needs to end up being negative 4. So let's try, yeah, negative 2. So that's negative 2, that's 3, that's negative 6. You got it, Tegan. And that's negative 4, and that's 0. So another answer then is x equals negative 2. Okay. Now this is just, since we started with a cubic, this is just a simple quadratic, what's left. And that we can factor. Two numbers that multiply together to be 2 and add to be 3 are 1 and 2. So my answers are x equals negative 1. We already had the negative 2 up there, so that has a multiplicity of 2. And then from the other page we had 0 also. So negative 1, negative 2, 0. The endpoints are negative 2 and 1. So we already have negative 2 and then 1. Okay? So you guys just have to plug those in. And well, so let's not do this part because you guys know how to do this part, right? You just plug these numbers in, you pick the biggest one, you pick the smallest one. If you need some practice doing that, then by all means go ahead and do that, and then I can tell you if you did it right or not, but there's no reason to waste time. Find the absolute maximum, biggest and smallest, yeah. These are our options for what to use for synthetic division, and they're the factors of this last one right here. Okay. Nice job, Shaden. Yep, he did. Okay, number 5, you ready? Yeah? Take the derivative. Derivative of sine is positive cosine. Yep, good. 2 cosine 2x, yeah. So the derivative is 2 cosine 2x. Because you have to take the derivative of this thing right there. It's a chain rule. No, the derivative of sine is cosine. Leave the 2x alone. And then the derivative of 2x is 2. So it's cosine 2x times 2. Well, the derivative of x is just 1, so it's not going to mess with that. So let's see, what's the right way to do this? So I got sine of 2x. Let's pretend that this is sine of w. What's the derivative of that? Cosine of w, and then technically we don't do this, but it's what Shaden and I were just talking about. You are supposed to multiply by the derivative of w, but the derivative of w would just be 1, so we don't do it, right? But in this case, w equals 2x. So I have to go cosine of 2x, because I put that back in there, times 2, because the derivative of 2x is 2. Chain rule, I see what you're saying. Chain rule is only when you're, when it's like inside itself, sort of. So the first step of taking the derivative is you take the derivative of this plus the derivative of that, okay, at the same time. So the derivative of x is 1, the derivative of this is this. I don't need to use the chain, like I don't need to take the derivative of this and leave this alone, and then take the derivative of this and then leave this, you know what I'm saying? Because these are being added together, so you just do the normal thing, okay? All right, are we squared away there? Okay, so I set this equal to 0. So 2 cosine 2x equals -1. I'm going to divide both sides by 2. So I need to figure out where you guys have a circle chart. Right, we'll mess with that in a second. So you guys have a circle chart. Where does the cosine equal -1/2? Remember, cosine is the, oh look, she cut it out in a circle. How cute. Cosine is the x-coordinate. So where on that circle does the x-coordinate equal -1/2? But oh wait, what's that? 2 pi over 3. Is there another place? 4 pi over 3. That's it. Okay. Because why? Okay, but this one is actually going to end up working because we haven't solved for x yet. Like Gage said, this is for 2x. Okay, so how do I get rid of this 2? Divide by 2. So that means in this case, right, in this case x would equal, good, and in this case x would equal 4 pi over 6, which is 2 pi over 3, which is in that range. So you do have to use that also. Okay? Okay, so you'd plug in 0, pi over 3, 2 pi over 3, and pi into the original thing. You want to practice that? Plugging those in? Well, you don't do it in a calculator. You do it using your circle chart. I guess you can do it on your calculator as long as you're in radians. You sign, and then the parenthesis pops up, so then you hit a 2, and then you make your own parenthesis, and then type in whatever x is. Shaden? Multiply both sides by 1/2 to get rid of this 2. Anyways, so over here, Shaden, the 2 and the 1/2 cancel, and over here, 4 pi, 6, 2 pi over 3. Payson? No. What are you trying to do now? Take this and plug it in? Are you trying to find the sine of pi over 3? Pi over 3 is the angle, so you'd have to go to the angle pi over 3 and then find the y-coordinate of that. But yeah, it's not even that because you have to double it first. So you have to go to the angle 2 pi over 3 and then find the y-coordinate there, and that's the sine of... And then the y-coordinate, because remember we're back to the original thing. Not your... Okay, so let's do this. All right, so our 4 things came out to be 0, pi over 3, 2 pi over 3, and pi, right? Right? So I'm going to plug 0 into here. So that's an easy one. That's 0 plus the sine of 0, which is just 0, so that means y equals 0. Okay? Then if I plug in pi over 3, well, if I plug pi over 3 into there, I get pi over 3, plus, to find the sine of 2 pi over 3, do you have your circle chart? Okay, you go to the angle 2 pi over 3, and then you find the y-coordinate of that point. Okay. So this, what I'm trying to get to you is this one right here is the angle. So you go to the angle 2 pi over 3 and then look up the y-coordinate. 2 pi over 3? Yeah. So what's the y-coordinate there? Right. So that right there. The reason why over here we did that backwards is because we weren't trying to find the cosine of 2x, we were trying to find what angle has a cosine of -1/2. So there we were looking for the angle. Here we're looking for the coordinate. Okay? I would not normally, but Gage said he would really like to try one of these for high stakes. So then if I plug in 2 pi over 3 into here, Payson, if I plug 2 pi over 3 into here, if I double that, that's 4 pi over 3. So now you have to find the y coordinate of the and then the last thing is pi. So the sine of 2 pi is, okay, kind of seemed like it. Should have a root 3 in it, doesn't it? Come on. No, I was yelling at my board. Okay, and then if you plug pi into there, the x becomes a pi. 2 pi, sine of that is 0. Yeah. So then you'd have to figure out which one of those is bigger. So in that case, Maddie, you'd have to do those on a calculator, I guess, and find a decimal. What about pi? Is that bigger than pi? Is pi over 3 plus root 3 over 2? Alright, well, I trust you guys can figure that out. Okay, and then we'll skip 6 because you guys are freaking out about trig stuff. Katie, are you on your phone because you don't have questions on this? Is that why? Gage, are you on your phone because you have no self-control and because you can't help but be on your phone? Okay. Did we have to do these? Okay. Are you ready? Are you ready now? Okay. The limit is 1/2. Highest power on top term, so this term right here is the highest one on the top. Highest power on the bottom term is 6x to the 4th. 3x to the 4th divided by 6x to the 4th is 1/2. Donezo. No, sometimes they will not be. No, it will not be. Yeah. If the power on the top is bigger, then the answer is infinity. You would say infinity, yeah. If the power on the bottom is bigger, then the answer is 0. Yep. If you don't feel like you can remember it. So basically you would go, if the powers are the same, then you just cancel. Top is higher equals infinity. Bottom higher equals 0. Yeah. Uh-huh. 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 Okay, Gage, the way that you do number 8 with the parentheses is, remember, we only care about the term that has the highest power. So I only care about what I get when I multiply those two things together. So this is basically the same as the limit as t approaches infinity of t cubed over 2t cubed. So that is once again 1/2. Yes. No. Good question. Same equals cancel. Okay. Okay. So the way we did these things is we divided by 1 over the highest power in the, we multiplied everything by 1 over the highest power in the denominator. So what I'm going to do, I think it's negative 2/3 because it's going to negative infinity. So what I'm going to do is I'm going to multiply the bottom by 1 over x, and I'm going to multiply the top by 1 over the square root of 1 over x squared. And those are the same thing, right? I did. No, because of the plus 1 is messes it up. I see what you're saying, and yes, basically your answer is, you're right. I'm just trying to do it like the math way. So if I multiply these two things together, and this is what you're talking about, the x squareds are going to cancel. I'm going to get 4. This one I'm going to get 1 over x squared. Here I'm going to multiply those together, and I'm going to get 3, and then multiply those together and get negative 1 over x. Okay? And so we had a theorem that said the limit as x approaches infinity or negative infinity of 1 over any polynomial was just going to be 0. Okay? I think let's see, I better look this one up. I might have been wrong. It could be positive 2/3. Because the x's all cancel. Let me look that up. The first time, since it's negative infinity, that makes it negative 2/3. Let's hope so. Doesn't seem like it, but you know. I mean, there's always exceptions, right? Yeah. Hey, Gage, could you put your phone away for a second and explain to Shaden the easy way to do this problem? Okay. All right, the limit as x approaches negative infinity of x squared plus x cubed. Remember we talked about you can't really do math with infinity when you're trying to add and subtract and weird things happen. But multiplication does kind of make sense. So I'm going to factor out an x squared. And then what does this go to when x approaches negative infinity? It's going to be infinity, because when you square it, you're going to get a positive number, right? Like if I put in negative 5 trillion into here, then I'm going to get positive something that's basically infinity. And then if I put in negative 5 trillion here, I get negative something that's basically infinity. And so when I multiply those two things together, then I'm going to get pi, okay?
If I put pi on one of these, do I get it?
Nope. I'm going to get negative infinity when you multiply two big old numbers like that together, okay? Right. Okay, number 11. Negative infinity, because positive infinity times a negative infinity is a negative, you know. Okay, hang on a second. How far did I tell you to do these before we got to do something else? What? To what? 16 on the test? All right, so this one I am going to multiply by square root of, 4x squared plus 3x plus 2x over the square root of 4x squared plus 3x plus 2x. Okay? Tomorrow, yeah.
And then we talked about stepping on Grady's stomach and a fish coming out, and he's like, yeah, dude, swallow a fish.
They canceled. Oh, where did it come from? Okay, this times this. Okay. Okay, so now I'm going to do what Gage was talking about, because that is a really good way to explain it. When we're talking about limits to infinity, we only care about the highest power, right? So I can basically ignore underneath the square root that 3x, and then the square root of 4x squared is 2x. So that means I can change this to the limit as x approaches infinity of 3x over 2x plus 2x, right? But then that's the limit as x approaches infinity of 3x over 4x, so that means the answer is 3/4. So I kind of like what you did there with that you just ignore those other things, which means then you can do the square root, and then you can go back to the simple, highest power over highest power. So thanks for that. No. All right, so then, no? Remember? Okay, so where are we headed now? Oh, I don't have 38. What does 38 say? This.
No, because I need calculate number 47 and
Okay. So find two numbers where the sum of the first number and 4 times the second number is 1,000. That's the first thing I've written there. And then we want the product to be as big as possible. So we're going to take the top one and solve it, I would assume, for x. So that means this becomes 1,000 minus 4y times y, which is 1,000y minus 4y squared. Not yet. Take the derivative first. Now set it equal to 0. So y equals 1,000 divided by 8, which is, I feel like, 1.5.
let's see. Yep, it is 1.5.
So 4 times 125 is 500. So then x also, x is okay.
Are you just funny how I spent 10 minutes on that problem?
Ho, 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 ho. Is that it?
47.
Okay, hold on. 2 more, 47.53. All right.
And
Oh,
54.
oh, yes. I took this first equation and solved it for x, and then took the x and plugged it into there. Yep. 125.
Just Rob, isn't it easy? Doesn't it appear to kind of fake? I mean, doesn't it appear to like, doesn't it seem like actually fake?
I was thinking, what if I did the bird box challenge and taught with a blindfold on?
You what? That's a challenge?
Teach.
That's a challenge?
What is the next one? Okay, so set it to $8 and then they sell out all the seats. Maybe. So the thing that we're trying to maximize is revenue, which is the price of the seat times the number of seats, or number of tickets, right? Does that make sense? Okay, so let's call the price of the seats X, okay? And then the number of tickets that we're going to sell is going to come from this information right here. What's the equation that you could write for that stuff? Let me put these, hold on, let me put these in the right order from larger to smaller. 11 and 12 are the same. Oh, yeah, right, because you multiply those together. So these are going down by 1,000 each time, right? Each time I'm thinking of it, I'm doing it the opposite way of Gage read the problem. If you raise the price by $1, they sell 1,000 less seats. Yes? So that means the revenue is going to be negative 1,000x plus how many tickets would they sell if it was 0? What's the y-intercept? Like if I go, obviously they'd sell 15,000 in the real world, but if I went 987654331 and I was going, oh yeah, you really, I guess you can do that. Um, what would that be? If I move this up to 0, I'd have to add, yeah, 23,000. And I'm not sure how they want us to deal with that because that's not a real possibility because of the size of the arena. But I'm just going to go with it. So negative 1,000x plus 23,000 is the formula for the number of tickets that I would sell based on the price. So if I distribute that, I get negative 1,000x squared plus 23,000x. What number is this? Okay, let me make sure that they don't want us to use 15,000 before we move on. No, they got something totally different going. No, we're doing it a little different way. Let's see if we get the same answer. Okay, hold on. The derivative of this is negative 2,000x plus 2,300, right? So you got to set that equal to 0. So you subtract, sorry, not 2,300, 23,000, divide by 2,000. What do you get from that? It's 1150, isn't it? Okay, so we got it right doing it kind of a different way. So they just charged $11.50. So Tegan was on the right track because he figured out that these two were the same. But those are sort of like 2 points on a parabola, and what we found was this point right here and this point right here, and so the high point was the point right in between those. That's where the vertex was. Okay. Gauge? Uh-huh.